Last week we did one thing in class. Remember when we put our hands together and open up our fingers like that? Yeah. So the wider you opened up your hand, the farther apart your fingertips became. Thought of that as an angle. The bigger the angle, the longer the side length it is across from it. Don't go all the way out. Basically what that means, first of all, I'm assuming you guys all understand that there's 3 sides to the triangle, correct? Which means there are how many angles in the triangle? 3. Okay. So what happens here is let's say this is 75, this is 70, and then that makes this one 35. Which one of those is the largest angle? The 75, angle A. Okay. Which one of those is the next largest angle? Angle C at 70, which therefore by process of elimination makes angle B the smallest with the measure of 35. You okay with that? Because how many degrees are in a triangle? 180, right? So if I did this correctly, 30, 100, yeah, 180. I mapped correctly. Okay. Now that means that this 75 looks at what side of it? BC. The 70 looks at AB, and then the 35 looks at AC. Take a guess. Obviously, this is not drawn to scale. Which one of those sides will be the largest? BC. Which means what would be the next largest? And what means it would be the smallest? Basically what this means, ladies and gentlemen, and this is a rule, in triangles, the small angle, the smallest angle, is always across from the shortest side. The medium angle, this is really, really tough here. The reason why I use the double arrows like that means that we're just going both directions. Short side is across from the smallest angle. The largest angle is across from the longest side. So you can list things and label things in specific orders. And really all you have to remember is the more you opened up your hands, the longer the side length would have been across from the angle. I know. Really tough, but I have a feeling you guys can figure this out. Okay. The smallest angle is across from the shortest side, medium to medium, large to large. Again, if you happen to have 2 of the same angles, that means you're going to have 2 of the same sides, because isosceles. If you have 3 of the same angles, you'll have to have 3 of the same sides, because equilateral. All those little properties and stuff fall back into this thing as well. Which means if I wanted to label from smallest to largest, AC, AB, to the BC. That's really tough. Yes. If you happen to have, let me rephrase that. How many obtuse angles can you have in a triangle? What is it? 1. You only have 1 obtuse angle because obtuse is more than what? 90. More than 90. So if you have an obtuse angle, that means all the rest would have to be acute and so on. See if you remember that. Earth ground shaking and earth shattering, really hard here, right? I know. We'll try and pace ourselves. I know. Okay. Right in order, largest to smallest for size. Again, I know. How many letters do you use for side lengths?
2.
How many letters do you use for angles?
1.
Only use one if it's the only one vertex. That's fine.
I think a lot of it goes back down to being able to just run the ball effectively over and over and over again.
All right. What's the longest side length? LN. Then what? And then what? LM and L. Doesn't matter which letters you put in order for those. Like I said, this is really tough. Really, really, really tough. One of the things that this gets is to be able to do that. This is where kind of the mapping comes into play. Is that we'll be able to figure out if you have certain side lengths given to you, if in fact you can make a triangle. Because what happens is, in order to create a triangle, one of the rules that happens is that the sum of two sides always has to be bigger than the third. So if you have three side lengths, that means there are three separate what we call inequalities that you check through. Right? So, like I was saying earlier, a lot of this gets really, 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 really complicated. Right, Billy? Come on, man. Sum of two is always bigger than the third. We always have to check. I'm making sure. I'm downplaying the severity of this. What's 3 plus 4? Is 7 bigger than 5? What's 4 plus 5? Is 9 bigger than 3? I have to have a British accent to sell it, oxy, please. I know, it was pretty Australian right there. Yeah. And then 5 plus 3 is 8 bigger than 4? Yes. So if it passes all three of those really, really, really tough math problems, it'll work. Yep. Yep. Has to pass all three. For example, if you have 2, 7, and 11. What's 2 plus 7? Right. Nope. No. Because what happens is, depending upon how the angle stuff gets maxed out, what did I say, 2, 7? Paper, 11 inches, 7, and 2. Tape. Okay, then you do it.
Unless you just like. No.
So tell me 3, 3, and 5 would work.
What's 3 plus 3? What's 3 plus 5?
3 plus 5 is 8.
And then what's 3 plus 5? So it works.
It has to be 90.
No, you said it has to pass all 3.
It does. What's 3 plus 3?
Or no.
I think I know what you're getting at.
It worked, didn't it?
4, 5, 9 doesn't work. 4 plus 5 is 9. It's not bigger than 9. That's greater than. And that's the idea here, guys. And then all 3 of them has to pass all 3 of them to make it work. If it doesn't, it won't work. Which then means you can do algebra. What are going to be the possible side lengths that you can have for the third side? Well, and that's the thing. If it's anything, what if it's 20? See what I'm saying? There's a range. So what we do is you wind up with 3 inequalities. And you have to figure out what works. What's 8 plus 3? Okay. Okay. How do I solve for x in the next one? Nope. How do I solve for x? Okay, what's 3 minus 8? Can you have side lengths that are negative? Nope, this one. So you wind up with a range. Basically, this says x has to be bigger than 5, but smaller than 11. X is bigger than 5, but smaller than 11. If I had side lengths of 3 and 8, the other possible side lengths are anywhere between 5 and 11. Not including 5, not including 11. Just bigger than 5, but smaller than 11. So 10.999999999999999999999999999999999999999999999999999999999999999999999999999999999 would work. Or 5.000. What? Anything bigger than 5 or smaller than 11. You okay there? Just try to get the tape weight. They're all on the tape. Let's try another one. Give me 2 numbers. And find the range of possible values. You have 3 inequalities to worry about. Not equals, greater than. Okay. What's 16 plus 32? 48. What happens in the middle? What? Can I have that? No. This gives me a negative value. That won't work. And what do you get for the last one? 16. X is somewhere between bigger than 16, smaller than 48. What do you mean? I wouldn't. No, no, it doesn't. It doesn't, because watch this. If I do 150 and 152. Oh, I see what you're saying. I'm sorry. I was thinking of a different set, yes. Because you have a larger variety. Yeah, I'm sorry. I'm not all the way up done with the coffee. Let's get it. Adam, well, here. Did you guys see the difference? What was going on? What was happening? Look at the range. 5 and 11. 16 and 48. Look at the numbers you started with. 3 and 8. 16 and 32. What's 3 plus 8? What's 8 minus 3? What's 16 plus 32? What's 32 minus 16? Adam, subtract them. That's your range. Adam, subtract them. What happens here, guys, what happens here if you're looking for just a straight number, you just add them together, subtract them. That gets you your range. Now, if you had algebra in there, which you very well could, let's say you had side lengths of 8, 12, and x plus 4. Solve for x, for the range. Then you have to worry about doing all 3 values. And it's not that it's tough. What's 8 and 12? 20. What do you get here? 16. 16 is bigger than x. Here you're going to wind up with, you get x plus 16 is greater than 8, but that gives you negative, so you don't worry about that. And then the other one, you get x plus 12. Is it okay to have something greater than 0? No. It doesn't say that it equals 0. So the values of x that could work here, there's anything between 0 and 16. Okay. Again, if you think about it, what's 0 plus x, or 0 plus 4? What's 16 plus 4? 20. What's 8 and 12? What's 12 minus 8? Math isn't all that tough. You just didn't want to be wrong. Okay. Now, what happens if they do this? What happens if they change your units? Okay. Do you convert up or do you convert down? Down. Yep. Always convert down. Now, one of the things that I'll hold you guys to are feet, inches, yards, miles, things like that. I'm not going to worry about metrics. I'm not going to worry about any fluid stuff. How many inches are in a foot? How many feet are in a yard? And then lastly, how many feet are in a mile?
8,000.
How do you guys not know this stuff? This blows my mind. You guys don't know this. A lot of times, things that I'm going to keep you guys account of when you're dealing with units. I'll keep things in terms of feet, inches, yards, miles, and things like that. Wow, you calculate, it doesn't matter as long as you know how many feet are in it. This is. Someone else told me about that too. Someone told me about that the second hour. I don't think I ever saw that movie, so.
What?
Oh shush! You guys never saw half the movies I say. Anyway, anyway, so 3 feet 4 inches. You always want to convert to the smaller unit. The reason why I say always convert to the smaller unit, that way you don't have to deal with fractions. You can convert inches to feet, just say that it's 1/3 foot, but nobody wants to do that. So how do you convert feet to inches? What do you have to do? Multiply or divide? By how much? So what's 3 times 12? You guys know that's the symbol for inches? The double take? So what's going to be the range of possible sides in inches then, with 36 inches and 4 inches? Just be able to rattle it off in your head. What's the range? How do you write it up? Okay. Remember, you add them, you subtract them. Sorry. All you gotta do is add them and subtract them. That's it. Okay, just add them and subtract them. And it goes up to that. What's the other weird one that shows up today? The other weird one that'll show up. What's the biggest angle? Angle A. What's the next biggest angle? Why? Why? What's that? 4x is bigger than 1x. Very good. That's what I was looking for. Sometimes they'll throw stuff like that. You don't have numerical values for the angles. You don't have numerical values for the sides, but you have inference that you can make. Remember how we kept talking a lot about this throughout the year about what information you take from diagrams? Well, we know that angle A being 110, it has to be the largest angle. There can't be any other angles in the triangle that are larger than that. So that would be the largest angle. The next largest angle has to be angle C. And the reason being is because if you look at the side lengths, 4 times something or just something. Well, if that something was 1, that means one side's 1, the other side is 4. Always going to be larger. Just wanted to make sure you guys saw something like that because it does show up. How many letters do you use for segment set? How many letters? Could I use 3 letters for these angles? I can, but I wouldn't just because it's just one triangle. We're not worried about double triangles. I don't think I did anything else, to be honest with you. Just want to make sure I showed you those. I know I'm pretty sure I posted this.
20 minutes.
We're not going to get like, wait, we're playing.
Do those, please. Okay, textbook up here if you want to take a picture of it. Quite honestly, you should be able to knock this out in about 7 or 8 minutes.